In this lesson, we're going to be talking about using Wireshark. Wireshark, as you can see here, is the world's most popular network protocol analyzer. Now, it used to be that these protocol analyzers or packet capture utilities or network analyzers were really expensive devices that you had to buy, and it required a lot of setup and you needed physical hardware. These days, it's just a piece of software, and Wireshark's been around for a while now under a couple of different names, and Wireshark is the most recent name, but they've been around for a while. It's a free piece of software, runs on just about any platform that you probably have an interest in running it under, runs under Mac OS, as you see here, runs under Windows, runs under Unix-based operating systems like Linux. And just to get started with it, it's a pretty simple piece of software, but it also does a lot of really complex things. And the reason for introducing Wireshark here is we're going to be spending a lot of time in Wireshark as we go through this series of video lessons. Wireshark is going to give us the ability to look deeply into the protocols that we're going to be going over, because I think that getting a protocol level understanding of what's going on really helps you understand networking and how systems interact with one another. It's also the best way to really see what happens, because in reality, the network can't lie. Applications make mistakes. Applications can generate misleading error messages or log messages, but when you're looking at what's on the wire can't lie, because at that point we're just talking about an electrical signal, talking about bits and bytes that are running across a physical wire. And so if you're looking for the best evidence as to what's actually going on with application interaction or going on your network, you really want to be looking at the network level and looking at a network protocol analyzer like Wireshark. So the first thing that I want to do is I want to do a packet capture. Now, there's a few different ways to kick off a packet capture with Wireshark. You can see on the left-hand side here, there is a capture box and there's an interface list. Now, I could choose any of these interfaces to capture from, and depending on what interface I'm using to connect to the network, that would be the interface that I would choose. Now, I can also go up here to the toolbar, and you can see I could start a new live capture. And if I click that, that's just going to capture from the default network interface. And so I'm going to stop that one. I'm going to close it. I'm going to continue without saving. So let me show you another way here. I can just go up to the capture menu item, and you can see I've got interfaces, options, start, as well as capture filters. And if I select interfaces, I get basically the same thing as I do with the interface list. The difference is, if I don't really know what interface that I want to capture from, then what I might want to do is bring up this dialog box, because as you can see, it's actually counting the packets on a per interface basis. And I can see here that EN1 is the interface that I'm actually getting a lot of traffic on. So I'm going to select Start there, and I can start capturing packets. You can see there's a lot of different menus, and we may get into some of these in a little bit more detail as we go through different protocols. Let me just show you a few different things that are useful. The first thing that you need to know about is filter. I've got all of these packets that are being captured. So far, I'm up to 78. And there could be hundreds or thousands of packets that I've captured, and I want a way to filter those packets. So if I just typed IP, for example, I'm going to be looking at all of the IP packets. Well, that's not particularly useful, because IP is a lower layer protocol, and pretty much anything is going to be sitting on top of IP. For the most part, most of the things that we capture are going to be IP packets, so that's not going to filter me very much. Now, I could do TCP, for example, and that's going to filter me down a little bit more. You can see that I've got a number of TCP packets, and in the protocol column, you'll see TCP, but you'll also see other protocols as well. And the reason that they're not all TCP is because other protocols ride on top of TCP. And we'll talk about the stack and how the different protocols layer on top of one another in another lesson. But you can see, for example, TLS v1 there. TLS is an encryption protocol that happens to ride over TCP. So I can do TCP. Now, I could also do HTTP, which would be web traffic. So I can see only web traffic. So that's really useful. Now, those are protocols. What if I want to filter by something like IP address? So IP address equals equals, because that's the syntax that we use. And let's say I want to do 192.168.1.43. One of the reasons I do that is because I can see .43 there. I happen to know it's going to come up. Now I've got just packets that are either to or from that particular address. I could also do IP.source or SRC, and I could do 192.168.1.43. And now I'm only going to get the packets where it's a source address rather than a destination address. Now, you can see as I'm typing here, the box is actually changing colors. So this red background color in the filter box suggests that I don't have a filter expression that I can actually use. The reason for that is I don't have a complete IP address, and Wireshark knows that IP.src requires a complete IP address in order to work. So once I get a complete IP address, now it goes green. So the green indicates I have a complete filter that can actually parse. Of course, whether it's going to generate any results is a different problem. Now, whether I've actually captured any packets that would match that filter, well, we're not actually checking that in the filter box. So I can do that. It's a parsable expression, but it doesn't necessarily mean it's going to yield any results. So I can filter based on protocol. I can filter based on IP address. Let me just clear that out. I can filter on just about anything that you can see in the packet here. And there's a pretty dense filtering language, understanding all of the different variables that you can plug in. But I'm just going to cover some of the basics here that we've already gone over so that you can see how you can start narrowing your filter and what gets displayed so it's easier to see what's going on. Now, one other thing that I can do, and I'm actually going to stop the capture here just to make it a little bit easier to see what's happening so we're not just having constant messages flooding through here. Now, what I can do is I could actually select a packet here, and if I right-click on it, I get a number of options. So I could actually apply this as a filter. So if I do a selected here, now I've actually applied that as a filter. So what I'm getting is packets that look like that. So you can see the filter that actually got applied is IP.dst equals 192.168.1.1. So that's the filter that got applied there. Now I could go find another packet here, and there's another thing I want to demonstrate that is really going to be useful. Actually, let me filter down by TCP again. And I could actually do this here. Now, what I could do is follow the TCP stream. So that's going to show me all of the messages related to that particular TCP stream. And in this case, what it's done is it's popped up all of the contents of the stream. So I can see, in this case, it's raw mode, and not really clear what this is, although it looks like it may be a CalDAV request since I can see calendar.google.com as part of it. So let me see if I can actually find an HTTP, which would be a little bit easier to follow here. And I don't happen to have an HTTP request. Let me start a capture again. I just brought up Google, and now I can go back to Wireshark. And I'm going to stop the capture, and I'm going to filter down to HTTP. Now I can do follow TCP stream here. And now you can see the HTTP content in clear text and readable. So this is what an HTTP request looks like here. And there's the GET request. And if I scroll down, I can see the response there as well. So you can see where that would be really helpful if you are trying to find all of the messages in a particular dialogue between two systems. If it happens to be a TCP flow, for example, HTTP, then you could follow TCP stream and it will show you all of the messages, and you can actually see the filter TCP.stream equals 10. It's actually flagged this particular stream as stream 10, and what we're looking at is all of the messages from that particular stream. So that's some basics around using Wireshark for capturing and analysis of packets and the different ways that you can do filters. As I said, we'll be using Wireshark quite extensively over the course of these lessons, and this is just to get you kind of familiar with the interface and how it operates.